Whenever measuring any common application like a pump or an electric motor for an ImproSeal bearing isolator, you'll find that the RFQ, or request for quote, sometimes called the 20 question sheet internally at ImproSeal, provides a really good guideline and a really good checklist for what you need to measure. First and foremost, in the field, most applications can be measured with a dial caliper, although there may be times you want to use a micrometer or something of higher precision. A dial caliper, though, is usually adequate for most of the applications for common bearing isolators. The single most important thing to measure with any bearing isolator application is the shaft diameter, where the ImproSeal is going to sit. And in that, simply carefully measure and record the measurement on the appropriate place on the RFQ form. Now, whenever measuring anything on a shaft diameter, it's normally going to be a nominal inch in 1/16 increments or a nominal metric diameter. If for some reason it's not, for instance, in this application, it's slightly bigger than 1.375 inch shaft, you may want to double check. It's not an indication that you measured wrong, but it's probably worth a check if you're getting something other than an even metric or an even 1/16 inch measurement. It could indicate that you've got a caliper off, or you're simply measuring a little bit off. Before doing anything else after measuring the shaft diameter, it's important to measure how far the first obstruction outside the face of the housing that the ImproSeal will sit into. Quite often this is a step in the shaft, but can also be a coupling, a keyway, or some other type of obstruction. This is located here on the RFQ sheet as distance to first obstruction. If it's a step in the shaft and it's relatively close to the housing, we can actually accommodate that with a stepped isolator. But when measuring to the shaft, be sure to include any radius so that we can get beyond that to a clean section of the shaft. Also make sure that after that step in the shaft, there's not a keyway or some other obstruction that's going to affect the ImproSeal. We may have ways of handling it. Just contact us if you need to. The housing bore that we're going to insert the isolator into or press into is normally in a cap or an end bell or some other component that can be removed from the face of the rotating equipment. Measuring the housing bore here is important to make sure we have a proper fit. Again, it will normally be an even 1/16 inch increment, or it will be in a even metric millimeter diameter. If not, double check. Also, check housing bores in a couple locations just to make sure that it's not egg-shaped or hasn't been worn. If it has been, it may require modification. On the 20 question sheet, or the RFQ, we also list the thickness of the housing and also the distance inboard to any first obstruction. Quite often there'll be a counterbore in the housing where a lip seal was pressed against, and this is going to limit our insertion room, and it's important that we know what that is when we make an ImproSeal for this application. Sometimes there is no counterbore back here and the space is open. In that case, it's important for us to know the distance to the first obstruction inside the housing. Normally this will be a bearing or something behind the housing counterbore. The reason for that is if this housing is relatively thin axially, our isolator may protrude out the back side of it a small amount, or we may wish to do that to provide a vertical lube retention, and we want to make sure we're not going to run into anything like a bearing or a lock nut on the bearing, or sometimes vibration monitors or speed monitors. There are types of devices here that we wouldn't want the static part of the isolator to run into, and we want to make sure that we have a lubricant return path. Also, in a counterbore housing, we want to assure that our lubricant return path in the isolator here is not blocked by a counterbore in the housing. So if there is a counterbore in the housing that would be blocking the lubricant return, it's important to also measure that and provide this. Another thing that's important on the RFQ sheet to note is where the lubricant level is in the bearing housing. Most often it's going to be center line. If it's a lubricant like oil, it's going to be center line of the ball at the bottom dead position of the housing. But if it's higher than that, or if the oil level is above the bottom of the shaft, we have a flooded condition, and we need to note that because it will require a different type of seal in the housing. To summarize, measuring a conventional motor, pump, or any other type of rotating equipment for a common bearing isolator is fairly straightforward using the RFQ or 20 question sheet as a checklist to make sure you've got all the appropriate measurements. Make sure your calipers are adjusted properly, that they're zeroed. If you're getting readings that are not even 1/16 inch or millimeter diameters, please double check. Check protrusion to the first obstruction. Make sure we've got plenty of insertion room and an unobstructed lube return, and that will fit most of the applications, at least 90% of those that you're going to run into in the field utilizing a standard bearing isolator. Thank you very much, and please contact us further if you have any other questions.